Hello friends, today we discuss about third chapter of CBSE, that is metals and non-metals. In this chapter, the introduction goes like this. There are totally 118 elements are present. So basing on their properties of these elements are mainly divided into three groups. One is metals, another one is non-metals, another one is metalloids. So let's see metalloids first. Metalloids are the elements which has the properties of both metals and non-metals. Like example, boron, silicon, germanium, arsenic, antimony, tellurium, polonium, astatine. These are all solids which has properties of both metals and non-metals. Next section is non-metals. Non-metals are generally total 17 non-metals are there. Among those 11 are gases like your hydrogen, oxygen, fluorine, nitrogen, chlorine, helium, neon, argon, krypton, xenon and radon. These elements are given a special name, that is inert elements, inert gases are noble gases. Next, we have a liquid nonmetal, that is bromine. We have 5 solid nonmetals, that is carbon, phosphorus, sulfur, selenium, iodine. These are 5 solid nonmetals. When it comes to metals, we have so many metals. We have almost 93 metals are there. All the metals are solids except mercury. Only cesium and gallium are solids at room temperature. They are converting to liquids at 29 degrees and 30 degrees Celsius respectively. So this is a story about metals, non-metals and metalloids. Let's talk about physical properties of metals and non-metals. So our topic starts with physical properties of metals and non-metals. So first property is, mainly we focus on metals and non-metals. Physical states. Metals are solids except mercury. At room temperature, all the metals are solids except mercury. You can see here along with the images I am showing clearly. So mercury is a liquid state at room temperature. So except that, remaining all metals are solid state. Whereas non-metals case, non-metals may be solids, may be liquids, may be gases. One non-metal is liquid state, that is bromine. This is your bromine. Bromine, it is a bromine which is in liquid state. Some non-metals may be solids like your, as we said previously, solids means maybe carbon, phosphorus, sulfur, selenium, iodine. This is examples for non-metal solids. Non-metal gases means fluorine, chlorine, hydrogen, nitrogen, oxygen. These are said to be non-metal gases. So that is a point regarding physical state. Next, lustrous. All metals shows lustrous. Most of the metals shows lustrous, and they can be polished also with the help of sandpaper. Whereas non-metals, they won't show lustrous. Most of the non-metals are gases, so they won't show lustrous. But exception is there, iodine. You can see in the image iodine. This iodine is a solid which shows lustrous nature. That is one exception for non-metals. Mainly we have to focus on exceptions. Hardness. Metals generally are hard, like iron, copper, zinc, they are hard. But some metals like your sodium, potassium, you can see this. These metals are soft. We can cut with the knife also, that much soft they are. Non-metals are generally soft, except your diamond. It's very hardest substance, natural occurring substance. Next, malleability and ductility. Malleability means ability to convert into sheet forms, whereas ductility means ability to convert that substance into wire forms. Ductility means wire forms, malleability means sheet forms. Metals are malleable and ductile, very simple. We can see in daily life. Take example of gold. Gold can be in wire form, gold can be in sheet forms. Both can be there. So metals can be in wire form, metals can be made into sheet form also. Next, whereas in case of non-metals, they won't show malleability and ductility, but they are brittle. Brittle means which are easy to break. Like example graphite of a pencil nib, which is easy to break. With a less amount of mechanical force, we can break it. That much soft they are. Next, tensile strength. Tensile strength means the maximum stress that a material can bear before breaking. When it is allowed to stretch or pulled, is said to be tensile strength. When you apply any mechanical force onto the substance, if it is able to bear, that bearing capacity is said to be tensile strength. That's the maximum stress that a material can bear, that is said to be tensile strength. Metals, practically metals, if you apply force with a hammer, it can bear the stress too much. That is why metals have generally high tensile strength and they cannot be broken easily at all. Whereas non-metals, they have lesser tensile strength, they can be easily broken, like your pencil nib. They can be easily broken. Still, we have exceptions also, like your diamond, all those things, not easy to break. But most of the non-metals are brittle and low tensile strength. Whereas next point is melting point and boiling point. Metals generally have high melting and boiling point. That means they need more temperature to boil or to melt. Exceptions are there. Metals like mercury, cesium and gallium, they have low melting point. We can see here very clearly. This is your mercury, this is your gallium, this is your cesium. The moment you touch these two metals, the moment you touch it, they come into liquid state. Because from our hand, the heat will be transferred to the metals, they can lose heat very easily. They can be converted to liquid state easily. They have such a low melting and boiling points. Whereas non-metals generally have low melting and boiling points, but diamond is having high melting point and boiling point. I hope I am clear to you. Next, density point of view. Metals generally have high density, very high density. But exceptions are there in this. Lithium, sodium, potassium, they have low density. We can see those metals. This is your lithium, sodium, potassium. These metals have less density. In fact, they are very smooth. We can cut with a knife also. We can cut easily with a knife. They are not like iron, zinc, copper, which are very hard. They are very soft. They have low density. They can cut with a knife also. Whereas non-metals generally have low densities. Most of the non-metals. When it comes to conductivity, next property is conductivity point of view. Conductivity may be conductivity of heat and electricity. So metals are good conductors of heat and electricity, as we know. They are good conductors of heat and electricity. Among all the metals, mercury and copper are good conductors of heat. Sorry, silver and copper, not mercury, sorry. Silver and copper are good conductors of heat. Mostly first highest good conductor is silver, next to copper. Whereas lead and mercury are poor conductors, very, very poor conductors. Whereas non-metals are bad conductors of heat and electricity. But we have exception here. Graphite, which is used in daily life as a pencil nib, that passes electricity very easily. That is one exception. We can see these metals: copper, silver, lead, silver this is, and this is your graphite, which is easy to break and it can pass electricity also, and this is your mercury. And the last physical property is sonorous. Sonorous means ability to make louder sound. Metals generally shows sonorous. We know this. In most of the belts we use metals, because when I apply force on the metals it makes louder sound. But non-metals does not show sonorous at all. They won't make sound like your louder sound like metals. I hope I am clear to you. Concept is clear, I think.